I would like to say a few words about our upcoming training, which is live online training that will help you design semantic technology POC and deliver a successful project for your business use case. The course will be held next Thursday, 27th of April. The training consists of 3 parts: per-class assignments, which include video tutorials and practical exercises, a live interacting class session, and individual consultation, which is optional. Thank you all for participating today. Now the webinar is all yours.
Hello. So it started getting like in the cinemas. Before you get your main course, you're getting a few promotions. Happy to see our marketing is getting more professional. So yeah, as Joanna said, yeah, I have presented FactForge several times, so this presentation will not be focused on FactForge itself, but rather on like few demonstration services that we developed on top of it, because well, not everyone in the world knows Sparkle and graph databases and reasoning. So I will start off with a demonstration of a new ranking service that ranks companies. Then I'll say a few words on how FactForge works and where we get the news from, because these rankings measure popularity of companies in use. And then I'll explain how what I demonstrated in the beginning works on top of these big knowledge graph that that we use in FactForge, and the news that we take from now. And I'll finish off with a demonstration of a new work that we've been doing. Analyzing and seeing how far you can get within a few days of work if you start, in this case, some tabular data about the connections between Trump and Trump-related companies and other companies and other people. So that's the plan for today, and I'll start off with the demonstration of the ranking. So just a second to minimize things. Good. The ranking service is public on rank.ontotext.com. So let's just get started. One can load one of the predefined rankings, but well, let's start creating new ones. So we basically measure media news popularity of companies across different industries and regions. And in terms of industries, you have about 40 top-level industries to choose from, and then you can choose a subsector. So in this case, we'll start with automotive. It takes a few moments to get this produced, because this analysis happens live on top of like 700,000 news articles that refer to, well, 300,000 or 400,000 different entities. So it's really broad coverage. And yeah, that's the global popularity ranking. That's the first piece of ranking that you actually see out of this system. Well, most of you probably haven't thought about wouldn't have guessed that Porsche Automobile Holding is the company that, if you consider the companies, I'm getting signals that the sound is not so good. So let me just make a quick attempt to improve it. I'm better off speak close to the mic. Excuse me for a second. Okay, I hope you hear better now. So Yeah, at first glance, it may appear strange that Porsche appears on the top. But what is special about this service is that we can of course measure direct references, but what makes the service unique is that we can make a combined score for the mentions of entities together with other entities with its subsidiaries. So all sorts of companies in the same industry sector that are controlled by this entity. And in this case, Porsche Automobile Holding is the majority shareholder of Volkswagen Group that on its own controls Volkswagen, but also Audi, Skoda, Seat, and a few other companies. So this is indeed the biggest automobile business in the world that is controlled by Porsche Automobile Holding, which controls Volkswagen, which controls 5 other car manufacturers. So what you see here is that in orange we indicate the direct mentions to the companies in the news, and in blue, added on top of them, this is the count of the news articles where, for instance, General Motors wasn't mentioned, but one of its subsidiaries was mentioned. So if you mouse over any of these, you can see the breakdown. So altogether we have about 1,500 mentions of General Motors, 1,700 mentions of various subsidiaries of Porsche Automobile Holding. You see that in this case, the holding company itself, it was mentioned just twice for the last 6 months, while most of the references, they actually come from the subsidiaries. You see the usual suspects, so that's very close to the top 10 ranking that you get here is very close to the rankings that you can get by revenue, by number of vehicles sold, and these kind of things. So one thing we can easily do is to make this more regional. So you can say, I don't care about everything on roads, but I want to see the most popular automotive companies in Germany alone. And well, you see what you expect: Porsche, Volkswagen, then BMW, and Daimler, Daimler AG, which now controls Mercedes-Benz. Now let's play a little bit how this looks like for the United States. Well, no surprises. The interesting thing is that although Tesla sells much smaller number of vehicles as compared to GM and Ford, it has half of the popularity of these giants. And that's a phenomenon that Tesla is way more present in the news because it does interesting, cool stuff that's now growing. So in this case, news popularity is way higher than if you want the sales volumes of vehicles or other things. For myself, I was able to make these kind of guesses also. But if I want to check who is who in China and to see the most popular automotive companies in China, well, that's really useful, at least to me, because I literally can't guess it. That's no way. And Geely, by the way, is I believe that's the company that controls Volvo cars. So there is a reason why this company is a bit more popular, and it gets a bit more mentions through subsidiaries, which is through Volvo cars. If we, final check on this kind of ranking, we can go to France. I'm just trying to give you a feeling that this thing is live, and you can make all sorts of combinations between industries, industry subsectors, regions, and yeah, you get decent coverage at least of the top players. So in this case for France, we see Peugeot, Renault, which are the two major makers. And in this case, you see Michelin. It's also, although it's not a car maker, they do tires, but that's still part of the automotive industry. So if we want to see just car makers, it's getting a bit more tricky, and you see that now Michelin is out. But this wasn't the main thing. So we're looking at trans, and let's see how this thing varies across the different over time. So if you take the last half year, 6 months back from now, you see that Peugeot scores way higher than Renault. And if we get only the last month, you can see that Renault scores better. The reason for this spike of popularity of Peugeot Citroën, as some of you may have heard of, is that well, about 3 months ago, Peugeot Citroën acquired Opel from General Motors, I believe. So you see how we can play and get these popularities for different time periods. Okay, let's. Well, one thing that I want to show to you as a quick demonstration is that as you keep playing with this, you can. Well, just a moment. You can actually share it. So if we get these scores for the last month, well, you can say, well, I'm really happy to see these results. I want to share it with my friends. And well, that's actually quite easy. So you automatically share it on Twitter, and yeah, I'll be able to see this. Don't look at my calendar. Like here is the popularity ranking of automotive companies during the last month, starting 20th of March. You click on it, and yeah, here you are. Anyone who sees your tweet is now able to see the very same ranking and keep playing with it. So let's continue. I'll make a quick move to a few other industries. So let's look at finance to give you a feeling how things may look like there. Finance actually includes many things. So it requires further analysis by subsectors, because when you put in one and the same category, banks, stock exchanges, financial information agencies like Bloomberg, it is getting a bit messier. This kind of comparison in this case doesn't make so much sense. So let's take a narrower look at banks, and you get a global ranking of banks. So and this figure is also not a surprise when you check it with other ways in which you can compare banks to one another. So one can get an easy proof that's quite close to the reality. If we want to see how this looks for a small country like Switzerland, oh, here you are, UBS and Credit Suisse. If we want to get global again, we can check another branch, another subsector, that is the mentions of venture capitalist funds in the last month, in this case, because we are still with this setting. But because these kind of companies are less outspoken as compared to automotive automakers, we better expand the scope, so we can switch back to 3 months, and you see the usual suspects. up there at the top. So yeah, this kind of thing works even for finance. We have one or two more sectors just to give you the feeling of how it works and that it's actually live. Before we switch to the explanation of how this works. So, quick check on oil and gas. Yeah, and again you get the usual suspect. One thing that we may want to do is say, well, let's have a closer look at gas-related businesses, and not all sorts of oil and gas, and then you get a slightly different picture. What about gas in United States? Well, you see the US players. Well, Russia sells a strong on gas, so we can check Russia. And yeah, because we live, well, most of the people don't live close to Russia, I can tell you, yeah, these are the two big guys, and Luko is indeed small one. Good. So, a bit of entertainment, because you probably got bored. So if you're wondering who are the biggest entertainment companies, we'll see the result now. And well, I have forgotten to switch off Russia. And it appears that globally, looking from the outside, the global news doesn't speak much about entertainment in Russia. They speak about other things in Russia. So if you go global and look at the last 6 months, yeah, we will see the biggest global groups of entertainment companies. Well, it takes a few seconds to get this loaded because, again, we work with 700,000 news and with a really big number of references to entries. So in each news we have about 70 tags that link the news article to to the big knowledge graph with all the information about the companies and their subsidiaries and industries and so on and so forth. So, yeah, I hope this makes sense. We see the Trump organization. I was always considering him an entertaining person, but I didn't expect that his organization would score so high. So, finally, because we do software, let's look at software. Well, there are plenty of reference software, so it will take a few seconds to get this loaded. Because well, there are plenty of references. As you see, we've been dealing with 12,000 references to Google in the news in the last 6 months, and about 9,000 for Apple and Microsoft, and then everybody else is small. And again, the Trump organization. Okay, these people aren't too modest. The first time when I got this result, I checked it, and they had just registered one of the holding companies within the group as being active in all sorts of industries. And we get information directly from Wikipedia, so we can't do much about it. But we have sort of get used in the last 6 months to see Trump everywhere. So yeah, so okay. So I think that's enough as demonstration, and I'll switch back to the presentation part to give you a better feeling how this thing works. Again, the service that I just showed is public; it's free. News are fed all the time, live, so anyone can play. If you enjoy the results, tweet about it, and that's it. So now a bit more technicalities on how this whole thing works. So Well, in general, Ontotext is, in Ontotext we believe that if we combine information from news with information from Wikipedia, with private information, with social media information, and sometimes for some products we also buy information from commercial vendors like Dun & Bradstreet or FactForge or Bureau van Dijk. Well, it's getting very interesting. You can do very good things if you use a graph database to combine this information. And further on this, for each of these objects that you have in the knowledge graph, you have so much different information, so much context that it makes it easier for you to analyze documents or news or everything else. And then from this news and documents and social content, you can extract more information and make better scoring. And this makes everything even more interesting. So the underlying technology is, as I said, a graph database, well, Ontotext graph database called GraphDB, which apart from these media ranking applications can be used as a graph database. So you can trace patterns, like be able to spot that Big Bricks Cafe actually controls my local cafe in New York City through a company that appears to be registered from the Cayman Islands. And these kind of things, like detecting complex patterns using inference. All these dashed arrows is actually inferred information. I'll demonstrate this later on, but as a technology basis, we combine this graph database with a service called now, News on the Web, which I will take the chance to quickly demonstrate to you so that you have a feeling where these statistics are coming from. Well, it thinks I'm here for the first time. That's why it shows an intro. Yeah, so you can see the top trends. That's not so interesting in this case. But if well, that's the news that just got in recently. This demonstrator is being fed by like 2,000 news articles per day. So it's an absolutely live thing. And you see that in the latest news that I found, you can see all these references to things like the Patrick Air Force Base and well, a person called FM Carl and many other entities like North Korea, if you haven't heard of North Korea, and so on and so forth. So we use text analytics to analyze the text and link mentions to entities in the text with the concrete object and the identifiers of the concrete objects in the big knowledge graph that contains like billions of tables about everything. And this is all sorts of news, like all the way from military to politics and other things. I personally don't have an idea who Jason Chaffetz is, so I'd rather give it a check and I can get quick information about it. I can see its trends of popularity. I can see other news that are speaking about this guy. And I can see what other entities it is related to in the news. Like it is being mentioned together with well, top politicians in the United States, parties. So, well, in this case, not much of a surprise. So you can play with this. Now it's also a public demonstrator, so well, anyone can go there and say, well, I care about business and get business news and trends in business news and analyze information this way. You can search, you can do many things, but in this case I'll stop it here because the main purpose of this was to give you a feeling where do we get this information about who is mentioned where. Well, we take this news from this other demonstrator from Ontotext called now. Good. well, I'll come back to this a bit later, and now I'll present to you FactForge. So essentially, this ranking service is well, nothing more than a sort of front end that serves specific purpose on top of a bigger platform called FactForge, where we combine linked open data, some of the biggest and most popular data sets like DBpedia, which is a structured version of Wikipedia, about 500 million triples. We also get geographic information about absolutely all sorts of geographic features on Earth. These are several million features described with 150 million statements, like facts about each of them. We get company information from different sources, like from a global registry called Global Legal Entity Identifier System. Last year we also did Panama Papers, so we basically incorporated in this data set and linked it to the rest of the data set that was published from the Panama Papers leaks, and a few other data sets. And all this is combined with the metadata that we extract from news. These like 200 articles a day that we get from now. So the entire data set, or if you prefer the knowledge graph that we play with now with these queries that, well, sometimes doesn't look as fast as you want it. Actually does very complex analysis on a repository that has more than 1.6 billion triples, of which 1.3 billion are explicit, and we have inferred, GraphDB has inferred about 300 million statements from those. A few more words about the kind of news that we get in. Well, these are roughly like 50,000 news per month. Altogether, we have about 700,000 news articles that we analyze to derive this kind of popularity rankings from. They're tagged, they have very rich metadata, but for each news article, you have a big set of annotations that link this article to semantics, be it companies, be it people, locations, general concepts, whatever. So out of all the entities that we have in the knowledge graph, those that are mentioned in even one of these news articles are about 400,000. So you see that actually news have very good coverage, and they tend to cover. They have a very long tail. It's not news that is speaking about 1,000 most popular things. It is a very rich stream of news across different regions and types of news, like sport and so on and so forth. And we have mentions of really broad range of entities. So I'll give you a quick demonstration of what we can do with this kind of platform before I go back to ranking. So one concrete application would be to search for, to try to detect suspicious patterns of control across companies. So there are plenty of people who, like risk management people, fraud detection, and other, who want to get information to be able to quickly find patterns, like find companies which control other companies in the same country through a company in an offshore zone. This was like the example you saw before with Big Bugs Cafe out of Seattle controlling my local cafe in New York through a company on the Cayman Islands. So to be able to do this, you need to have control relationships. You need to have associations between companies and countries. That's not always trivial with open data. And well, of course, you should know which are the offshore territories. That's the query, and now you see live. I don't expect you to understand how it works. We go to FactForge. Well, because I'm in incognito window to make sure that you get the true experience of a newcomer, it will take a few seconds to load all sorts of scripts. But after that, it will be fast, I promise. Good. So essentially, FactForge, at FactForge, it is a more technical platform, so it allows people to explore the plain graph data and to do queries in a language called Sparkle. That is the language for these kind of graph databases. Well, I think I got something wrong here, so I will open it in another window. Good. So that's the query, and it essentially says I want, and that's the Sparkle query editor. I want company C1 that controls company C2, which controls company C3, and I want C1 to be in country C1, and I want C3 to be in the same country C1. So the first and the third company in the chain are in the same country. The second is in a different country, so C1 should be different from C2. And we want C2 to be a country for which we know that, well, there are some offshore provisions in this country, to put it in a politically correct fashion. We make this query on top of this, like 1.6 billion triples. And, well, it takes 12 seconds to detect a number of patterns like this. So you see, for instance, that well, Bertelsmann is a big media group in Germany, and it turns out that Bertelsmann in Germany controls RTL television, that's again in Germany, through RTL Group, which is registered in Luxembourg. And Luxembourg is precisely one of these countries for which we have this offshore special regime and offshore provisions. So for those of you that are there in US, Luxembourg is, well, in a way, the European equivalent of Delaware. So, well, you can do these kind of things with FactForge. There is a big number of sample queries, some number of sample queries that you can play with. You can search. So if we want to search for the Trump just a second. Okay. Well, we'll do this search demo later on. Yeah, you see a lot of Trump things, including Trump organization and others. But we have a more specialized demo for this one. So that's just a demonstration. Well, that's not the right Trump. Anyway, let's go back to the presentation and continue the story because we are running out of time. So I present to you essentially what this ranking service is based on. It's based on a linked open data management platform regarding information for people, organizations, locations, as well as news. I demonstrated how we can do this kind of complex query patterns, and now we can go on and say a few more words about the ranking service, and then we'll have a few minutes with the data about Trump. So, as I said, it's unique for the fact that we have streaming news and you get free live service of ranking by news popularity. That's absolutely unique by being able, at no extra cost, to also trace subsidiaries. And some of these big international companies, they have many subsidiaries. we basically, this hierarchy of sectors that we demonstrated, it is derived from the industry classifications of DBpedia. But to make it easier to deal with, because there are like 900 different identifiers in DBpedia about the industries, we made a hierarchical taxonomy where we have some 40 top industries at the top, and then another 251 sectors in the hierarchy below that. The major work was to make the hierarchy, to identify some top industries that make sense, and to do the deduplication. Because as you can imagine from the like something that comes out of Wikipedia, there were a lot of variations of how people do these kind of things, and how people like identify retail companies. So you can see retailer, retailing business, retailing industry, and those sorts of variations. So we did. We invested several days of work to make a proper industry taxonomy out of that. And yeah, as I said, it is entirely based on FactForge, but it is meant to be demonstrator that doesn't require any technical skills to deal with. So again, if you want to publish the most, well, let's see whether Trump has something to do with fashion. Well, luckily he's not in the top 10, and you see the brands you expect. So you can, well, easily, but not from here, not from this browser, also share the results, be it on LinkedIn, be it on Twitter. Good. So let's move on. About Trump world data. Let me find the right browser window. Just a second. Some time ago, earlier this year, we went across a project called Trump World Data. So it is driven by like 4 journalists from BuzzFeed. So they collected and unified information about Trump and companies and people related to Trump from different sources like declarations and other things. And they made this information public in Google spreadsheets. So you can see a relationship between organizations and organizations, person and organization, person and person, and so on. So we said that's perfect. So let's start playing with this. And I'll show you just that. I have an instance of. Let me just find the right window. I have an instance of GraphDB locally. So I'll just start from scratch. I'll create a new repository, hopefully. Just a second, because the panes that are here for the webinar platform are making it a bit hard for me to access the right side of the screen. We create a new repository called, well, Trump repo. Then we can choose several parameters. I will not bother you with this now. And we create the repository. Well, but it's not the active one. We created it, but there is another one that is active. I put this on. And then the next thing that I have to do in this mini project is to load some ontologies that I'll briefly show to you later on. So I select several turtle files, that special form of RDF, and import all of them in GraphDB. This will take just a few seconds. And now I have a repository that contains well, just some schema level information, taxonomies of relationships, and these kind of things. Altogether, just 700, well, 500 explicit statements and some inferred stuff. So, just a second. Now, let's see how we can import this tabular data about Trump. So, since GraphDB 8.0 that was launched back in November last year, we have something called Ontotext, which is essentially an integration and customization of OpenRefine that was before Google Refine and so on. So you can essentially pick. So you can pick a concrete file out of the many formats that are supported. Well, let's start with the one about relationship between organizations and organizations that I have just downloaded from the Google spreadsheet published by the BuzzFeed guys. We open it. Then it is getting processed, and I see a sample of what the table would look like. Like if you have organization A, organization B, the type of the connection, and so forth. I can say that that's fine. I don't need any tuning in this case. So I let Ontotext to process this data. And now we essentially have a virtual repository where we can, well, either see this data from a table, either do Sparkle queries against them. The first thing that I did when I saw this information is to say, well, there seem to be plenty of different types of relationships between these objects. So let's see what the relationships are. And in Ontotext you have a feature that comes from OpenRefine. You can do facets. So I can very easily do a facet of all the values in this column, sort them by count, and I see that out of like 700 rows and plenty of like 83 different types of relationships, about half of them are ownership, and then 90 are investors, and so on and so forth. This is useful when you make your mind how to interpret your data and how to analyze it. So we did this. We did the same for the other types of information, the other two tables. And now it is time to let me reload this one. No, not this one. Just a second. Okay, we choose the right repository, and then in order to import the data, we should write essentially a simple Sparkle query that queries the virtual repository and then imports the data into the repository of your choice. We run this one, and well, it takes a few seconds to get this table loaded in RDF. It will be done very, very soon. So we get like 5,000 statements imported from the table that links organizations to organizations. Now let's import the relationships between persons and organizations. It will take another few seconds to get this done. And we have another 7,000 statements imported. So what to do now? Well, one thing we can do is to try to search, but we're getting an indication that autocomplete is off. That's why I want to switch it on and use this feature of GraphDB that allows me to well, more easily find information in big repositories by the names of the identifiers. Because I'm doing a bit too many things. Yeah, there is some interference between this webinar system and my machine, because that works instantly. You can play with FactForge and see how this works, even for much larger repositories. Let me. Well, let me continue with some further work. So, one thing that we can do in order to be able to handle better such information is to use another feature of GraphDB that is called RDF Rank. So we can compute RDF Rank for this repository, and this essentially gives us for each node in the RDF graph the kind of rank that Google uses for web pages. So it's based on how connected and how important is this node in the graph. We use this for several purposes. One of them is to make better suggestions in case of auto-completion for really big knowledge graphs. And in this case, you see that when we start searching for Trump, we get well, some of the key entities in his network up there at the top. So if you search for Donald, and you get Mr. Donald Trump himself up there at the very top of this ranking. Figuring out what, I mean, there is plenty of information about this guy. So we see a table of more than 500 facts that are not always so easy to interpret in tables. So a new feature in GraphDB 8.1 is this visual graph exploration. So you can see, well, the Donald Trump is big here because it has a big RDF rank. So this entity is measured to be important in the graph. So the size of the circles that identifies this kind of importance. So, well, when I started exploring this, well, you can essentially open and explore further any of these nodes. So I said, well, let's see how Donald Trump is doing in Europe. There is a company called DeConnect Europe Limited. And we can analyze and see that out of the many different relationships, we have made a taxonomy of different relationships. So there are 20 different relationships which may represent that someone has interest in some entity. This information is consolidated, and we use it to, we can directly explore these type of relationships, abstracting ourselves from the 100 different types of relations. So we see that Donald Trump has interest in this DeConnect Europe Limited, but there are also Donald Trump Jr. And Eric Trump, who also has interest there. We can also expand these nodes, and we see that, well, actually, Donald Trump Jr. and Donald Trump well, share the interest in quite a number of entities. And if we extract Eric Trump, we start seeing a pattern that well, you see like at least 3 companies where each of these 3 guys has some interest. Now the question that we can ask ourselves is how we can detect more patterns like this, because we've been lucky and we saw this one just because it happened this way. But what we can do to find such patterns and to use the power of the graph database is to write a query that says, well, let's search for organizations which are and use types of relationships that are special cases has interest, and then let's search for agents 1, 2, and 3 that are all related through this type of one and the same type of relationship to one and the same organization. So precisely the pattern that we observed visually. So let's search for such patterns, and there is a bit of filtering to get the information in a more readable form. So we run this query, and we basically see that, well, this pattern that we saw on the screen is indeed there. So we see that Eric Trump, Donald Trump, and Donald Trump Jr. and Donald J. Trump, there are 3 organizations in which they co-appear together, and these are those companies that we already saw. But there are more patterns like this, which in this case involve Donald Trump, Eric Trump, and Rona Rizzo. And there are other people who are involved in these kinds of patterns with Mr. Trump. So that's a demonstration of the type of analysis that you can do if you load this tabular data and if you make a sort of hierarchy of relationships. So this is where ontologies and inference help. We have made an ontology where we say, in this specific case, we only care about persons and organizations, which are special cases of agent. And then there is essentially a taxonomy of different relationships. Well, most of them are a sort of business relationship, and they range from someone being contracted to somebody else, also a former contractor, that is a special case of contractor, and so on and so forth. And then you see that this, for instance, this relationship that we've been tracing has interest in a specific company. It is a business relationship, and there are many other relationships like chain influence and so on that complement each other. So, for instance, we have a relationship shareholder in. That is a special case of someone having some control in an organization. That on its own, if you have control over one organization through ownership, you can influence this organization. But you can also influence this organization if you are a manager who can represent the organization, and so on and so forth. So we have a taxonomy of like several hundred different relationships from this data set that are organized in such a way that you can abstract yourself from different types of ownership and say, I don't care what, tell me whether someone can influence one organization or whether someone has interest in another organization, and so on and so forth. So this is work in progress. So we plan to publish this data set and provide some sample analytics on top of it, and made it open for further analysis quite soon. So that's one of the demonstrators that are coming quite soon. So you will also be able to download this data because the data sets are not that big, or to play with them directly from the FactForge service and be able to combine this information with all the other data sets that we have. So that's all that I had for today. You can play with these services. The major thing that we present today, the ranking service, rank.ontotext.com. You can play with Now, that is the semantic news exploration thing. And for those of you which are more technology savvy, you can go straight on to FactForge.net and do the complex analytics. Thank you very much. Sorry for being a bit late.
Atanas, thank you for the insightful talk. Dear all, thank you for your time and for attending this event. This webinar is being recorded, and with the presentation will be available in a few days. If you came up with any questions, please just reply to the email with the recording or write to us at events@ontotext.com. And there is one question.
Can you read it for me, please?
Yes. I'd like to have the ontology, please.
The ontology, I guess the person is asking for the ontology about Trump words. Well, yeah, just drop an email and we'll share it. That's the kind of project like the Panama Papers database that are completely open. So you can have access to the ontology, to all the transformations that we needed to start with these analytics. So you're very welcome.
Thank you all. See you soon.